How many moles of oxygen gas will be produced from 7 moles of water or H2O? Find a balance equation that describes the reaction. After balancing, identify the information and what the problem is asking you to find. In order for us to solve the problem, we must cancel units and calculate. And there you have it. 7 moles of H2O or water produce 3.5 moles of oxygen gas. How many moles of H2O will be required to make 22.5 moles of H2? Find a balance equation that describes the reaction. After balancing, identify the information and what the problem is asking you to find. In order for us to solve the problem, we must cancel units and calculate. And there you have it. The answer is 22.5 moles of H2O. How many moles of ammonia are produced if 4.20 moles of hydrogen are reacted with an excess of nitrogen? First, find a balanced equation that describes the reaction. After balancing, identify the given information and what the problem is asking you to find. In order for us to solve the problem, we must cancel units and calculate. And there you have your result. The reaction of 4.20 moles of hydrogen with excess nitrogen produces 2.80 moles of ammonia.
So, let's now proceed for another example. In this equation, first we need to identify which substance is the limiting region. So, what we do first is, well, definitely the first things we want to do, of course, is to convert these masses into moles. We're gonna multiply by 1 mole over 28.9 gram, that is the molar mass, and do the cancellation. So, now, let's do the same for the nitrogen. We're gonna take 1.50 grams of nitrogen and gonna multiply it. And next to that, let's do the cancellation. And we ended up having 0.0536 mole of nitrogen gas. The next step is Oh, just a quick reminder, guys. Limiting reactant is not automatically the substance in a lesser amount. So let's take our moles of silicon and multiply by 1 mole to product for every 3 moles of silicon. And next to that, let's do the cancellation. Then we get 0.0237 of silicon 3 nitrogen 4. And now, let's do the same for the amount of nitrogen that we have. And we're going to multiply by 1 over 2 because we have only 1 to 2 ratio with the coefficients moles of nitrogen. And next to that, let's do the cancellation. So that we can get the 0.0268 mole silicon 3 nitrogen 4. So the fact that silicon would make less of the product than nitrogen could upon both of those substances reacting completely. And now we need the theoretical yield. We need a molar mass of silicon with a subscript of 3 and nitrogen with a subscript of 4. And if we tally up those, we will end up having 140.28 grams. And next to that, let's do the cancellation. And we ended up having 3.32 grams. And that is now our theoretical yield. And lastly, we need to know the percent yield would be. So first, let's remember its formula, which is the percent yield is actual yield over theoretical yield times 100.
Okay, so learners, the problem is if 15 grams of copper chloride react with 20 grams of sodium nitrate, how much sodium chloride can be formed? To solve this problem, kindly check if the equation of the problem is balanced or not. If the equation of the problem is not balanced, write the balanced equation for the reaction given. Okay, so learners, after balancing the equation, let us now proceed on converting the grams into moles. So let's convert the given 15 grams and 20 grams into moles. Okay, so let's start first with the first given, 15 grams of copper chloride. So 15 grams of copper chloride, multiply it with 1 mole, and after multiplying, find the molar mass of the involved elements, which are the copper and the chlorine. And after finding, the result is 134 grams. And after that, do the cancellation. So 15 multiplied by 1 mole divided by 134, the result is 0.11 mole.
So the same with the second given, 20 grams of sodium nitrate multiplied with 1 mole, and after multiplying, find the molar mass of involved elements, which are the sodium, nitrogen, and oxygen. And upon solving the molar mass, the result is 85 grams. And after that, do the cancellation. So 20
multiplied with 1 mole divided to 85, the result is 0.24 mole. So the new given here is the 0.11 mole of copper chloride and the 0.24 mole of sodium nitrate. So, learners, on finding or solving for limiting reactant, let's start first with the sodium nitrate. So, how much moles do we need with sodium nitrate? So, first, write the given 0.11 mole of copper chloride, then multiply it with 2 moles of sodium nitrate, divide it with 1 mole of copper chloride, which can be found on the equation. So, before solving for the moles needed, do the cancellation first and then proceed. So, 0.11 multiplied by 2 divided by 1, the answer is 0.22 moles of sodium nitrate is needed to be performed. So next, let's find out how much moles is needed for the copper chloride. So write the given 0.24 moles of sodium nitrate multiplied with 1 mole of copper chloride, then divide it with 2 moles of sodium nitrate before doing or performing the solving. Do the cancellation and then proceed. So 0.24 multiply it with 1 mole divided by 2, and the answer is 0.12 moles of copper chloride. So as we can see on the sodium nitrate, we need 22 moles of sodium nitrate, and the given is on sodium nitrate is 0.24 mole. Okay, so on the other hand, learners, we need 0.12 moles of copper chloride, but the given is 0.11 moles only. So in short, the limiting here is the copper chloride and the excess here is the sodium nitrate. So listeners, after knowing which is the excess and which is the limiting, so let's go back with the excess because we will solve for the excess left over. So upon finding the excess left over, just simply put the given, which is the 0.24 mole of sodium nitrate, and subtract it with the needed moles, which is the 0.22 moles of sodium nitrate. So subtract 0.24 and 0.22 is equal to 0.02 mole. So the excess left over is 0.02 mole of sodium nitrate. Okay, so learners, after learning about the conversion from grams to moles down to solving or finding the limiting reactant and excess left over, let us now proceed to the finding of the percent yield. So, on finding the percent yield, we should first distinguish or solve for the theoretical yield. So, what if the 11.3 grams of sodium chloride are formed in the reaction? What is the percent yield of this reaction? So, it is still connected with the first problem from the first discussion, which is the limiting reactant. So, I'll repeat, if 11.3 grams of sodium chloride are formed in the reaction, what is the percent yield of this reaction? So, on finding the percent yield, we should first distinguish the theoretical yield. So, on finding the theoretical yield, we have to distinguish first the reactant mass. So, the reactant mass of the given problem is 15 grams of copper chloride. So 15 grams of copper chloride, multiply it with the quantity of mole of reactant or 1 mole of copper chloride, divide it with the reactant's molar mass or the 134 grams of copper chloride, and then on the second row still, and the numerator part, multiply the product's molar quantity. So the product's molar quantity is 2 mole of sodium chloride. So 2 mole of sodium chloride divided with reactant's molar quantity, which is 1 mole of copper chloride, and then still multiply it with product's molar mass, which is 58, and divide it with product's molar quantity, so which is the 1 mole of sodium chloride. So for easier understanding, just multiply all the numerator and multiply all the denominator, but before multiplying, make sure to do the cancellation. So do the cancellation, multiply the numerator, multiply the denominator, and then divide. So as we can see, 15 times 1 multiplied by 2 and multiplied by 58 is equals to 1740, and the denominator 134 multiplied by 1 and multiplied again by 1 is 134. So 1740 divided by 134 is equals to 13 grams of sodium chloride. So our theoretical yield here is 13 grams of sodium chloride. Okay, so lastly, learners, let's solve for the percent yield. So the formula for the percent yield is equal to the actual yield divided by the theoretical yield times 100. So our actual yield here is 11.3 grams. So 11.3 divided by with our theoretical yield, which is 13. So 11.3 divided by 13 times 100 is equivalent to 86.9% or 87% yield.